Right on. What's good, Logan? So this is a quick set of notes just to help you guys out with today's assignment. Um, if you have two options, one, you can either just follow along and then do the assignment, or you can actually write it in your notes. I'd highly suggest you guys write it in your notes. All right, so really quick, brief overview. What we're going to be doing now is we're going to be solving quadratics, and we're going to have complex solutions come up every once in a while, or maybe all the time in this homework assignment. But in general, they can show up whenever they show up now, just like real solutions. So when solving, what you're going to want to do is you're going to want to deduce your radicals when they come up. You don't want to wait last minute. So for example, we're going to take a look at the assignment that you see in front of you. And what I want to focus on is question number one. We got x squared plus 36 is equal to 0. So I'm going to zoom this guy in just a bit, just so we can see it. Let me get it right for you. All right. If I'm going too fast, then by all means, slow it down. All right. So change the speed. But if this is going too slow, then speed it up. If you need to pause at any point in time, just pause. All right. So for problem number one, x squared plus 36 is equal to 0. The first thing you're going to want to do is get rid of the 36. So I'm going to subtract the 36 from both sides of the problem. What this does is it leaves us with x squared is equal to negative 36. So we have x squared is equal to negative 36. Now the reason I'm choosing to solve it this way is because it is in vertex form, and when it's in vertex form, it makes the most sense to just solve by isolating the x squared. So I'm going to square root both sides of the problem. Please remember, when you square root both sides, to include the plus and minus on the non-variable side. On the right side, we get the square root of x squared. Sorry, take this back. On the left side, we get the square root of x squared, which is just equal to x. So on the left side, we have x. But then on the right side, what we want to do is we want to simplify this. Now, I'm going to do this one time this way, and then after that, we're just going to keep doing it the more quick way. We're going to simplify this by changing the square root of negative 36 to the square root of negative 1 and the square root of 36. Now, remember, our definition states that the square root of negative 1 is equal to I. So now we can say that we have positive negative I times, and the square root of 36 is 6. Now we want to rewrite this in its standard form. So we're going to write it as x equals both positive and negative 6i. I would write your answer as two separate answers. X equals negative 6i, and then our second answer is x equals positive 6i. All right, let's move on to question number two. Question number two, we have x squared plus 20 equals 7. Once again, notice that you only have the one x squared right there. There's no other x's. I would go on to say that this is really close to being in vertex form. So we're going to go ahead and subtract the 20 to isolate the x squared. So we take away the 20 from both sides of the problem. This gives us x squared is equal to negative 13. So we have x squared is equal to negative 13. At this stage, we're going to go ahead and square root both sides of the problem to isolate the x. This is going to give us the square root on the left and the square root on the right, remembering to put the plus and minus on the number side. The square root of x squared simplifies to just x, and we have x equals positive negative. Now, you take the square root of a negative value, that's automatically going to be I, so I'm going to say I square root of 13. Since we can't simplify the root 13, we have two answers. Our first answer is x equals negative root 13i. Once again, notice how I like to put the I at the very end, because it is in standard form, and x equals positive square root of 13 with an I. And those are our two answers for question number two. All right, moving on to 3 and 4. Like I said, if this is going too fast at any point in time, slow it down or just stop it. Question number 3, once again, notice you have just a single x squared right there. So what we're going to do is we're going to isolate the x squared by taking away the 35 from both sides of the problem. Subtracting the 35 is going to result in 5x squared is equal to negative 35. So we have 5x squared is equal to negative 35. Then we're going to divide both sides of our problem by 5. This is going to get the x squared isolated and by itself. The result is going to be x squared is equal to negative 7. All right, from here to isolate the x, that means we want to get rid of the square. We're going to take the square root of both sides of the problem, square root the left side, and square root the right side, remembering to put the plus and minus. The moment we square root, we also notice that we have a negative in the radical, so I'm going to go ahead and rewrite this as x equals positive negative. The negative in the radical indicates that we're going to have an I, and square root of 7. And if we can simplify the square root of 7, we will. We can't, so we're just going to write our answers as x equals negative square root 7i, and x equals positive square root of 7i. Both of them have I on it because there was a negative inside the radical. Moving on to question number 4, virtually the same exact idea, isolating the 3x squared. We're going to go ahead and add 7 to both sides of the problem. Once again, when it's in vertex form, it's always in our best interest to get the x squared by itself. This gives us 3x squared is equal to negative 24? So we have x squared, 3x squared equals negative 24. We're going to divide both sides of the problem by 3, dividing the left side by 3 and the right side by 3 results in x squared is equal to negative 8. So we have x squared is equal to negative 8. Trying to get the x squared, the x by itself, we're going to go ahead and square root the left side of the problem. That's going to get the x by itself, but then we have to square root the right side to balance the problem out. Remembering to put the plus and minus, we get x equals positive, negative. Now, since it's a negative inside the square root, I'm going to write the I, and then I'm going to reduce the 8. I'm going to reduce the 8 as the square root of 2 squared times the square root of 2. I should say, not reduce it, but rewrite it so that I can reduce it. This is going to give us x equals positive and negative I times 2 square root of 2. Now I'm going to go ahead and rewrite our two answers. The two answers we have, number 1, x equals negative 2 root 2 I. And our second answer is x equals positive, you don't need to write the plus sign, 2 root 2 I. So our two answers are negative 2 root 2 I and positive 2 root 2 I. Okay, continuing on with the notes. The next thing that you're going to be asked to do is to find the zeros of the function. Now to find the zeros of the function, what you're going to do is it's a process of setting the function equal to 0 and then going ahead and solving it. So you'll notice in this problem here, we started off with f of x equals 2x squared minus 22. Now, like it says, to find the zeros just means you set the function equal to 0. And that's exactly what we did right there, is we set the equation, the function equal to 0, and then we would go ahead and solve it like we did the last problems. All right, let's take a look at an example. Our first example, problem number 5, what we have is f of x equals negative x squared minus 81, and we're going to try to find the roots. Sorry, I take that back. We're going to try to find the zeros of that. So we're going to start off the problem by writing negative x squared minus 81 is equal to 0. And we solve it just like we did the other problem. So it's going to be the same exact technique, adding 81 to both sides of the problem. What we end up getting is negative x squared is equal to 81. So we have negative x squared is equal to 81. Now remember, we're trying to get the x squared by itself, so we want to get rid of the negative 1, so we're going to divide, or the negative sign, we're going to divide both sides of the problem by negative 1. The result is x squared is equal to negative 81. X squared equals negative 81. Now, trying to get rid of the square on the left side of the x, what we're going to do is we're going to use the square root, and when we use the square root, we have to do it on the other side, and we're going to put the plus and minus. Always put a plus and minus when you put a square root into a problem. This is going to give us x equals. Now, since the square root is negative, we're going to say positive negative I, and then the square root of 81, which happens to be 9. We're going to go ahead and simplify this into two answers. Our first answer is x equals negative 9I, and our second answer is x equals positive 9I. A lot of students will ask, why did I not simplify the 9? The simple answer is there's no square root on the 9, so I should not reduce it. 9 does not equal 3. It is the square root of 9 that is equal to 3, and there is no square root on that 9. All right, moving on to question number 6. Now this one's a little trickier. What we're going to do is the same exact thing we did in the last problem. We're going to take the function 1/3 of x squared plus 24, 1/3 of x squared plus 24, and we're going to set the function equal to 0. Now, after we set the function equal to 0, the first thing we're going to do is we're going to get rid of the 24, so we're subtracting 24 from both sides of the problem. The result is going to be 1/3 x squared is equal to negative 24. So we have 1/3 of x squared is equal to negative 24. Now, in trying to keep the x squared by itself, we're going to go ahead and multiply the left side of the equation by 3/1, or the reciprocal of 1/3, which happens to be just 3. So you don't need to write 3/1 on both sides. You only need to write, you actually don't need to write it on the left side at all. So on the left side, what we end up getting is 1/3 times 3/1, or 1/3 times 3, which is just x squared. So we have x squared equals, and then 24 times 3, which is negative 72. So we have x squared is equal to negative 72. Getting the square off of the x means we're going to need to use a square root. So we square root the left side and the right side, remembering to put the plus and minus into the problem. The result gives us x equals x equals positive, negative. Now, since the 72 is negative inside the radical, we're going to have to use the I to represent the imaginary number. Now, 72 can be simplified. If you need to do your table on the 72, by all means, please do so. So divide by 2, and so forth. What I'm going to do is say that square root of 72 is the same as the square root of 36 times the square root of 2. For those of you that knew that, do it this way. For those of you that don't, well, you're doing the table. 2 goes into 72 36 times. 2 goes into 36 18 times. And you can extend this even further. All right, we're going to go ahead and keep simplifying this thing here. This gives us positive negative I. Square root of 36 is just 6. Square root of 2 cannot be simplified. So I'm going to go ahead and rewrite my answer to make it look a little bit nicer. So we have x equals negative 6 square root of 2i. That's our first solution. And our second solution, or I should say root, or 0, sorry, our second 0 is positive 6 square root of 2i. All right, if you have any questions, please send me an email and I'll try to hit you up as soon as I can. Otherwise, best of luck on your homework. Make sure you get it turned in class, and I'll see you guys hopefully on Wednesday. Peace.